Welcome everyone to the 10th annual 2021 Student Research Symposium. My name is David Cox and I'm the Director of Scheme Library, OSL, and the SRS. The SRS is an annual campus-wide event that provides both undergraduate and graduate students the opportunity to present their research in a variety of formats: poster sessions, oral presentations, and a 3-minute speech competition. We hope you will join us for these events over the next few days. Thank you for joining us today for our first event, Poster Session 1. The SRS is grateful to Tech faculty member Dr. Isabel Morris from Civil Engineering and former Tech employee and Tech alum Liz Lyons for their assistance today. Dr. Morris will be moderating today's session, and Ms. Lyons, with the help of SRS staff members, will be assisting with tech. Now, during normal times, if we can call anything normal anymore, the SRS would take place in person on our beautiful New Mexico Tech campus. But because of COVID-19, we are here in the virtual world, and this is the second year that we are virtually presenting the SRS. This session that you're going to attend is a poster session, and several New Mexico Tech students will have the opportunity to present their research to you, and you will be able to ask questions, so please be prepared to do that. In a moment, Dr. Morris will start things off, but first, a brief word from an SRS staff member.
Hi, everyone. My name is Sarah Obanoff, and let me get to my script. Okay, so we just want to go over a few things today before we get started. Because we have a lot to cover, this is how today's session will unfold. Each student or group will give a brief presentation based on their poster, and the moderator will facilitate questions from the audience. During the presentations, all of you will be muted, so there's no background noise or interruptions. When the time comes for Q&A, you will be able to unmute yourselves and ask questions. The chat box will remain open throughout the entire session. If you need technical assistance, please feel free to send a direct message to Liz. For ease of use and access, the moderators, volunteers, and presenters are at the top of the participant list. A couple of things. We hope upon hope that there are no technical difficulties or problems with internet access today. If we do experience a problem, please be patient as we work to solve it. If a power outage or some major event happens, we will contact you via email apart from the meeting if you have already provided one to us. And here's a suggestion for the session itself. You might want to change your settings to speaker view, which makes the visuals and the presenters on the main thing which makes the visuals and the presenters the main thing on your screen. From time to time, we will be posting the link to the poster gallery and the evaluation forms in the chat box, so you can take a look at the posters throughout the session and fill out evaluation forms as you like. And so we ask that you please fill out these evaluation forms as often as you are comfortable with. You will need to fill out a separate form for each poster or group. Thank you again for joining us. Let's begin. Dr. Morris?
Hi, everyone. Thanks again for joining us for the beginning of SRS and Poster Session 1. We have 22 presenters and 11 posters to get through this morning. So keep an eye on the chat. I see now there's a link to the evaluation and the poster gallery. So you can open that up and have that tab if you want to zoom in on posters or anything like that. The poster presenters are here with us live, and they'll be available for questions. So I'm going to start off. I'm going to say the name of your poster and the number of it for anyone who's looking, and then I'll have you introduce yourself and go ahead and unmute yourself, turn your video on if you can, and share your research with us. So our first presenter is from Mechanical Engineering. This is poster number 114. This poster is called AI-based damage assessment of buildings after earthquakes using drones. Hamed, are you here?
Yes, I'm sorry, I came late. I should explain my poster or just answer the question?
Yep, so if you can give a short spiel of your poster, an overview like you would if I walked up to you in a poster hall, and then we'll get some questions probably, but you can go ahead and get started.
First of all, I'm Hamid Moumeni, working as a PhD student in mechanical engineering, and this is a mechanical project. It's a portion of my thesis. During this project, I'm working on a network of drones and equip these drones with the AI methods. Then the goal of this whole system is assessment the building after extreme events like earthquake. Assume that after an earthquake, there are lots of buildings that are damaged, or lots of buildings we can use them immediately for occupation. Then as conventional methods, we need experts to show up walking through the street and find the safe buildings for immediate occupation, but we should be more fast. Then for this project, I defined AI-based damage assessment drones. They're equipped with high-resolution cameras, and we have several assessments. For the first initial assessment, we compare the shape of building as a cuboid. Any variation from cuboids show us there is a extreme damage on the building. For the next step, we should order the drones to go more approach the nominated buildings and find and collect the more detailed data. One of the detailed data is the surface crack pattern on the brittle structures like concrete. For this method, we use robust principal component analysis as a real-time and time-efficient solution for extracting the cracks. And then we have the pattern as a sparse matrix. Then we can do further analysis to find the severity of damage. Then this is the real-time process. We need real-time processors to analyze a huge bunch of data as a high-resolution videos to extract the crack patterns. And the main challenge here is this. Then the future boards focus on the improvement this method, and of course adding other steps. That's it. I would be happy if you have any questions.
Thanks. I can ask a question while the audience, I guess, gets warmed up or thinks of other questions. I am curious about how you're going to move from this case study to a more general or to any other videos.
Okay, this sorry, which step I cannot see your cursor. This is not a case study. It's two steps, okay, two different steps. The first step work on overall shape of building and check them. The second step checks the surface crack pattern. Then one step is on the whole building, one step is on the element. But then an element, but in buildings we have vital elements like shear wall. If a shear wall is damaged, severely damaged, then we cannot use the building.
So I guess what I meant was that by the case study, I was just meaning the initial kind of crack patterns that you were recognizing. But sorry. Do we have any questions from the audience?
I was wondering, so the programming that's on the, is it the programming that's with the drone? Does that give the results immediately? I was only, and maybe I just didn't read it well, but I wasn't clear on how quickly the results of the analyses was coming back to, say, first responders who are looking for safe buildings to move populations into, people into, after one of these events.
For the first step now, we use convolutional neural networks to check the building, but for the second step, I use robust principal component analysis, or RPC. This method is real time because assume that we have a full HD video with a 30 frame per second. As a hand calculation, we have 80 million data points, I mean the pixel value, but the robust principal component analysis can analyze each frame on the real-time goal. Then it can send the result. The embedded processor can decide how it needs more data or no. That's enough data and can tag the building.
So it's got a real fast turnaround for the, and is this something that it's, will the data be pretty easy to get to first responders?
Mm-hmm.
Okay. That's fantastic.
Thank you.
This is a short question, but are the videos from like a one fixed reference point, like, and they just are continuously looking at the same location on the building, or is the video moving around on the whole structure?
The camera is mounted on the drone, okay?
Yeah.
Then it's depend on our decision where the drone is stated. It can be stay in a one location, look at the wall, or we can order him to change the location.
Okay, thanks.
Yeah.
Are there other questions?
Sorry, I have a question. One of the weaknesses that you identified was that if there is significant sway, background sway, this method wasn't as effective. And I guess I have kind of an obvious question, but I don't know that much about the events that this would be useful. But how long does it take for that to dissipate after an earthquake? Is that days or weeks? And would this method be more effective if it were brought in after that period of time?
Sorry, I didn't get your point. What dissipated? The earthquake dissipated, or the, I don't know.
The sway after an earthquake, the background sway.
Oh, okay. Yeah, it is assumed that it's an extreme sway. Then the building is out of service. Okay. Sometimes during the earthquake we have some sways, but the building come back.
I see. Okay.
The sway is zero. We cannot find it by this method.
Ah, okay. Thank you.
You're welcome. That's we need the next step to more analyze.
May I ask a question?
Of course.
I see that you're really at your beginnings, but in a great beginning of this, talking about needing further analysis for a comprehensive method. What are some of the ways you're looking at trying to promote that from this point where your poster has been presented? And are there places where you're really excited about going to next?
Another step we should add here is comparison the buildings, the situation of building after earthquake between this situation and the previous situations. We have the satellite image as a simple one. We have access to Google Street View. Then they show the overall shape of the building. We can compare these two types of image. And this show us the vulnerable buildings, which buildings are severely damaged, which buildings can be nominated as safe buildings, and we can send the drones to evaluate them in more detail. This is another step we should add. And another step we can add to this project is using a network of drones, because here I focused on one drone. Then they can be interconnected. For example, the data can be synced with and one system can choose the next manual.
Thank you.
You're welcome.
Great. So thanks, Hamid. I think we can move to the next presentation. My Google account has just decided to refresh, but I believe it's from Mineral Engineering, and this project is called Analysis of Copper Mining Accidents in the United States from 2010 to 2019. So if your group is ready, you can go ahead.
Hi, good morning, everyone. So I am Carla Barreto, and I am an undergrad here at New Mexico Tech in the Mining Engineering Department. And in this project, we have Joaquin Robel, Julianne Asoma, and Bracy Chester, and we're all students within the department. And our emphasis and main focus for this project was to try and understand why copper accidents happen within the industry, how frequently they happen, and the numerous amount of causes for these accidents, and how they could all, in one generic way and in some ways, be addressed to help these accidents not occur as frequently. So I'm going to go ahead and introduce it more. Mining is the extraction of minerals such as gold, diamonds, and aggregates within the raw materials of the global economy. And these raw materials form the basis for agricultural manufacturing and electrical generation in order to provide the quality of life enjoyed in the United States and other developed economies. Copper mining is important to the US and global economies. And according to the Mine Safety and Health Administration, these copper mines in the United States within 2019, they are an increase for demand, especially for electrical vehicles and raw materials that we specifically need. And we definitely utilized MSHA's data and everything within those sub years from 2010 to 2019. And that was one of our main important methods, as well as Python. And the experimenters within this project, we would like to draw an emphasis to specific accidents where the highest injuries occurred, with the intention of perpetuating effective and preventive solutions to future injuries. We also began to analyze the data after data filtering in order to understand the relationships between categories such as the total mine work experience, the age and injury severity, and days lost as well. And we had a lot of graphs to show because there's so many different causes for mining accidents, but a lot of them, if they could be addressed, not only would it increase the industry itself, but most importantly, increase the safety within the mine workers. And within these data, some of them weren't exactly correlated. In the middle graph, you can kind of see it's quite small, but sometimes even with mine injuries and age, it doesn't always necessarily occur just because of someone with little experience. Sometimes even someone who's been at a mine site given maybe 20 years with experience, because of complacency and just kind of getting used to the job and thinking and within our heads that we know how to do this and we find shortcuts, and that could actually lead to more accidents. And there's not one real prevention for everything. We can only educate the public so much and try and help people communicate more effectively so everyone is actually understanding why these accidents occur and what we can personally do to prevent them. And not to mention that not everyone thinks the same or picks up on this knowledge as well as everyone else. So that's a whole different side of mining incidents that needs to be understood on a whole psychological level. But it is recommended that for further research, we undertake the various existing behaviors based on safety programs in order to determine which methods could be more effective in producing a desired program for work safety and awareness to reduce overall accidents within the industry. And I will let my other research partner, Mamaita, talk as well.
The first graph we can observe on the PowerPoint is showing total accident and copper accident in mining in the United States from 2010 and 2019. We can observe that accidents nationwide across all minerals are decreasing, while in copper mining, we observe an increase from 2017 and 2019. The second graph shows us that the majority of accidents year over year are actually caused by stroke. And the third graph shows us that the amount of days a mine has to stop its activity due to an accident. And we can observe that the worse the accident, the more days the mine has to stop operating. Thank you.
So with that said, we'd like to conclude that there currently exist training programs are somewhat inadequate at addressing and reducing root causes issues that continue to lead to these injuries. Especially because a lot of these injuries have occurred since way back then. I mean, we're talking 1980s. And although some of those issues have been addressed differently through OSHA and MSHA regulations, they still occur and they still have a huge impact. And recordable rates fluctuations seems to be more closely tied to production rates than to improvement in the employee health and safety culture. So further analysis is needed to make a genuine, smart, and realistic enhancement to the health and safety programs geared towards increasing awareness and employee participation, especially the participation, because a lot of employees at any age may not want to always speak up, some more than others. And that's not just necessarily speaking up. They don't want to communicate sometimes that they don't fully understand why that's occurring or why we have to lock something in place or wearing our PPEs during certain situations, and they really effectively need to. The goal is to make safety the primary focus of every employee on site, regardless of mining experience levels, in order to fundamentally improve the overall safe and health culture. As a result, this team is recommending that the copper mining industry looks towards more behavioral-based safety programs that empowers the employee to take more of an active role in health and safety. This shift is creating more of an ownership and responsibility within the employee for not only their safety, but awareness for the safety of coworkers as well. And the goal is to start every day and every task, every job by pausing to take time to discuss the hazards and focus on safe execution. The risk of every job executed cannot always be eliminated, but awareness can be increased, discussed, and mitigations put in place, and risk properly managed. So that kind of concludes our introduction, and we're open to any questions that anyone may have.
Thank you all. So I have a question. I was curious if there's any change in kind of the roles that people or the tasks that people are doing that is linked to the amount of experience someone has, and if there's a relationship between what roles or tasks people are performing and injury prevalence.
Hi, Isabel. I'm in this part of this group as well. And we didn't exactly look at the tasks that people were performing or their job duties. But that would be a good place for us to look at in the future.
Thanks.
I have a question also. When you go to any mine or any larger industrial thing, the first thing you do is go through a safety program, right? And the mining industry, and certainly Freeport and some of the other ones that are just local here in New Mexico, are absolute safety is their first thing that they always talk about, right? So how are you going to be able to change the culture of that when safety is already the first thing they talk about, and they say it's the very first thing, without, how can changing the culture happen if it's already part of the bigger part of their culture?
So with that said, we can try and implement that's the culture within the mine site. In other words, you can go, say Peabody, you can go to a coal mine and all they talk about is safety, safety, safety. And you try to have safety talks all the time. But it's almost, how do I explain this? You're almost trying to put in a culture that really isn't accepted by everyone. With that, what I'm trying to say is it's not that people or employees aren't accepting the fact that they need to be safe and they want to come, just as someone comes into the mine, we want them to leave the same way. But I think a main thing that you need to do to make sure that the culture is actually 100% effectively being implanted is by communicating with everyone and communicating a little bit more efficiently. So you have to try and recognize, and this is where the behavior works comes into this part of mining. You have to try and recognize the behaviors of the individuals that you work with. And it's a bit more on a psychological level than anything, and that's something new that's coming into mining. So you have to try and understand your employees a little bit more. You have to try and recognize those who try to speak up and those who don't. And everyone has a bit of a different personality. So it's kind of trying to take a different perspective on trying to have everyone play a role and try to get them to talk and be more involved. Rather, that means changing up the style in which you have your meetings, having smaller meetings, or having sub meetings in between each part, whether it's the equipment or the people who run the dozers or the shovels or the drag line, and the engineers as well. So I guess what I'm trying to say is you're right. It's hard to come into a mine whose culture is already safety. So how do you fix something that you're already trying to implement? And that just kind of comes to another perplexing question. Is it fully being implemented? And it's not. We can say that safety is our 100% goal, but if everything was safe and we were doing everything 100%, no one would get hurt. So that comes down to the individual. And that also comes down to understanding the person. Do they really care? Is it because they're fatigued? Is it because they don't pick up on things and learn as quickly as others? So we're still developing on how that's going to happen and be implemented in the mining field. But it comes down to learning the behavioral patterns of each individual as well and who you're hiring. I don't want that to sound as something negative, but it does make a difference. If the person is willing to understand more and not be so caught up on the fact that they have the mine experiences, doesn't mean that they have to bend the rules. So I think communication is a huge thing, and you also have to understand your employees, what kind of things effectively work for them. You can't have them sit on a 3-hour meeting about safety and expect all of them to understand everything you're saying. You have to change things up. So I'm not sure if that answers your question a little bit.
Well, it covered it fantastic. The mining industry of my grandfather's time is certainly not the mining industry of our time right now, right? And certainly the mining industry is not hiring the same type of people that they used to hire, right? The mining industry used to just take anybody and everybody because it was dirty, nasty work, and nobody wanted to do it. Now, you know, with the culture shifts that we've been having, the pay that the mines are being able to offer and the safety that mines are being able to offer, the mines are certainly able to be a lot more picky on who they hire and how they hire.
Well, and to go off of that, it is all about continuous improvement. And like you were saying, the mining industry has gotten a lot safer. For example, I believe since the 1904, the whole industry is 1,000 times safer than it used to be. So it's about using, you know, the data and the previous 10 years to inform the next 10 years on what the accidents that were caused. So that way we can use that in future training programs. And for example, we didn't show it on this graph, but the most commonly injured body part for copper mining last 10 years was hands. So that just shows that, you know, we need to put more education in that and maybe more trained well. And as Carla said, the goal is to, you know, have zero accidents and every miner to return to leave work as they started work. And on the bottom left, we see that, you know, the mining industry as a whole is having improvements, but that there definitely could be room for improvement. So it's about just using the data to inform future training programs.
Yeah, just to add on to what Joaquin said, I've actually had a personal experience at a mine site that I had worked in with these other fellow, they weren't interns, they were employees of the mine who were coming in to weigh haul trucks and the volume of the haul trucks. And these guys, they weren't wearing gloves. And that bothered me a bit. So I spoke up and I said something about it. And they weren't terrible employees. It didn't mean that they didn't know how to do their job effectively, but you get complacent. You think just because you have this experience under your belt that you don't need it, or you don't know that the chain is just going to come off of your hand and burn it or cut it or something, and it's unexpected. And there are those great chances that nothing's going to happen. But then it goes back to how much risk you're really willing to take. And like Joaquin said, it's important to kind of go back to history in the sense of all the data and analyze everything that it's happened. But there's so much that we can do to nail it into someone's head that they can't do it this way, and who's willing to listen. So there also has to be that adjustment in behavior and understanding those components, as well as understanding the data and why it's occurring.
Yeah. So I think we should move along a little bit. Thank you all. Changing culture is hard. So I'm sure if people still have questions or comments, you can use the chat. So our next talk is from biology. This is Mitochondrial Genome Architecture and Recombination in the New Zealand freshwater snail.
Yeah, that's my poster. Good morning, everyone. Okay. So basically over the summer, I was tasked with helping Dr. Joel Charbonneau in his research with confirming divergent structures found within the mitochondrial genomes of these snails. And so the reason why we need to use these snails is because Dr. Charbonneau's research really deals with the intersection of the mitochondrial genome with the nuclear genome and how evolution has shaped that interaction, because if there's no interaction between those two genomes, then the organism basically won't be able to live. I mean, mitochondria is the powerhouse of the cell. So we have to make sure that, you know, everything is coordinated with other functions within a cell. And so the reason why these snails are used is because they're an organism that reproduces both asexually and sexually. And because because mitochondrial genomes are passed down maternally only, this kind of gives us both sides of the coin when looking in how they coordinate with the nuclear genome. So the need for this additional validation on already existing data arises from the fact that mitochondrial genomes in mollusks are notably complex, and this does not exclude these freshwater snails. So these complexities can include inverted repeats, strand asymmetry, and unusual tRNAs. And you can actually see one of the unusual tRNAs in figure 3 below. It's like kind of the second one from last. It has a missing D loop. So kind of some of the steps I took was I started with the characterization of tRNAs, and I did that using a bioinformatic software called tRNA scan. So I took the data that Dr. Charbonneau already had, which was the code for the tRNAs, and I basically put it into this software, and it gave me image files, which I organized and named according to anticodon and put back into the Google Drive for the lab group. And so once I was done making sure all the structures were named and organized, I moved on to the actual mitochondrial genome, where I used the bioinformatic tool XPASI to go through and actually annotate where the 13 protein coding genes stopped and started. So this included just basically using a tool like Notepad to go through the actual code and make sure what Dr. Joel Charbonneau had said about their position was correct. And if it was not, I would go and annotate where the protein actually started translating to where it stopped translating. So going through all that, I was able to find all the 13 protein coding genes and their open reading frames to produce the expected amino acid length. Specific interesting things that I found included the COX-1 gene to have a possible polyadenylation, the NAD3 gene to have the unusual start codon of ATT, and all the 22 tRNAs were present and accounted for. And like I said, the serine tRNA had a missing D loop. So further direction for this data and efforts to validate this data include making sure that we correctly validate everything, first of all here, and then moving on to confirm the tRNA remodeling that we observed in figure 4, and also to confirm the length and presence of the inverted repeats that we observed in both mitochondrial genomes. And after everything is validated, all of the information will be edited and annotated, and hopefully it will be published as a paper. Thank you. Does anyone have any questions?
Thanks, Emily. I am definitely not, I don't know anything about genetics, but I'm curious about what the implications of these kind of weird features that you identified are. Like what does knowing or identifying those help you understand about these genomes? You're still muted, yeah.
Sorry.
It's okay.
So that's like, it's kind of hard to make the stretch of like, oh, this is really interesting and this is important because mostly I don't really have a full understanding of what Dr. Charbonneau is doing. I just know that it is something to do with evolution, and the mitochondrial genomes of mollusks are just really different from some like organisms like us, like vertebrates. Like we don't have any inverted repeats or missing D loops or anything like that. And so it's important to study mostly because mollusks are really ancient organisms, and it might give some insight into how we all evolved, I'm imagining. But yeah, that's the best answer I can come up with.
Yeah, thanks. Yeah, so it's related to like how the mollusk has continued to, I guess, thrive for so long.
Yeah, they're very like hardy, steadfast organisms. They've definitely been around a while.
Cool.
So I got a question too. So
sure.
How do your snails get sent to you?
So we get them, I think, from his colleague and collaborator. I think who is in like maybe Montana or Minnesota, I'm not sure. I know we get them from a collaborator, actually probably back in like California. I'm not sure. They're actually they're from New Zealand, but they're very invasive. So you can actually find them pretty much anywhere.
So do they come shipped to you like from FedEx, or I mean, are you opening an envelope with just like snails rolling around in it? How's that happen?
I mean, I think they're pretty much just shipped to us. I don't know if FedEx is what we use. Maybe it's UPS. I'm not sure.
Cool.
So I am definitely not a STEM major. I'm English lit background, but I find this type of thing fascinating. This might be a really simple question. You talked about mollusk study in general, but what is it about the New Zealand freshwater snail specifically that makes it a good test subject, or is it even a good test subject?
So it's a good test subject because they're able to reproduce asexually and sexually, which basically means the female doesn't need sperm to produce eggs, but they also can produce eggs with sperm. So like they have two options for how to reproduce. They can basically clone themselves, or they can, have sex. So that's why there's such a good system to study for this kind of research, because mitochondrial genomes are only passed down maternally. The asexual, when they reproduce asexually, there's no recombination that the mitochondrial genomes have to deal with. But when they reproduce sexually, there is a recombination of the nuclear genome that the mitochondrial genome has to account for. So we basically get two sides of the story with these snails, if that makes sense.
It does. Thank you.
And a quick question, can only the females reproduce asexually or both sexes?
I'm pretty sure it's only the females.
Okay, I wanted to make sure I wasn't misunderstanding. Thank you.
Yeah.
Thanks, Emily. We can continue moving on. Our next presentation is from an electrical engineering group presenting a pulse laser diode driver for Langmeyer Lab.
Alrighty, hello everyone. So my name is Ethan Wade, and I am the team lead for the team that is doing the pulsed laser diode driver project. Just a brief synopsis of what the project is. Essentially, Dr. Edens at Langmuir Laboratory asked us to create a pulse laser diode driver that we would use to pulse a 650 nanometer laser, or a red laser, into a shadow graph system that he has in order to take pictures of things going on in hydrometeors. So I'm Ethan Wade. The other people who worked on this project are Eric Friedrichsen, Dakota Marquez, Torrin Sameth, and Enrique Nahara. Our project advisor was Dr. Anders Jorgensen, and I'll let Enrique take the next part.
Hello, everyone. My name is Enrique Nahara. I'm just going to give a little more information on what we actually are working on here. So a pulse laser diode driver, essentially, as Ethan mentioned, we're going to be pulsing a laser within specified restraints and characteristics. We need to achieve certain timing characteristics. We need to achieve certain size characteristics, and as well as using certain hardware components. So as you can see below in the first column, that is an image, a 3D image of what our PCB, the first revision of our PCB, looks like, developed in KiCad. We used KiCad to develop the schematics for it and had it shipped off, and we are in possession of that actual board. We just finished soldering them yesterday. This first revision is going to be used for testing purposes, just to verify that we're meeting our goals. And we are going to be ordering a second revision here shortly. The second revision of our driver circuit is going to include a couple of different things on the back of the board. These things will include a microcontroller circuit to provide a transistor to transistor logic signal coming from a microcontroller. And the other circuit is going to be a power supply circuit on the back. Moving on, another team member will take the background section.
So in terms of just like the background of our project, so the purpose of the laser diode driver, like I said, is we are sending a sequence of pulses to a laser diode. And essentially, we are sending these pulses based off of a transistor logic signal, or just a TTL signal. And all that really is some kind of square wave signal that we get from a separate microprocessor that's also going to be handling the shadow graph system and the CMOS sensor that's going to be receiving the light and things of that nature. And so the shadow graph system essentially just passes an emitted laser through various optical elements. So we have Dr. Edens was telling us that the way he is envisioning it's going to go when he actually puts it in the system is we're going to have a beam splitter going into a beam collimator going into an optical filter that is designed for the wavelength of light that we are going to be using. And so basically in this project, all we're doing is creating a square board with holes at 60 millimeters by 60 millimeters that can be integrated into this optical system so that he can use it for the shadow graph.
So part of, obviously, this is we need to confirm that our board is doing what we want it to do. There are two main things we need to look at. We need to confirm that the laser diode is pulsing at the correct times. So this means it's a little bit more of a complex pattern. So we need a pulse pair. So we need two pairs or two pulses occurring close to one another. And then we need a longer pause in between those pulse pairs. The length of each pulse, the time between each pulse in the pulse pairs, and the time between the pulse pairs all need to be set and constant. We also need to determine that the laser produces the same level of light each time in order to get a good image from the shadow graph. So in order to do this, two methods were used. We used an O-scope to confirm timing. Oscilloscopes are very useful for this kind of thing. They're very quick. They can really show a lot of detail, but they are a bit bulky and expensive. So part of the project was developing kind of a simpler, more lightweight, cheap version of kind of a crappier O-scope, so that when this is being set up in the field, the team will be able to confirm the laser is pulsing as expected. This was done using a photodiode and a transistor to essentially create a switch that will allow 5 volts to pass through when the light pulses. This 5 volts is then picked up by a outside microcontroller, in this case an Arduino Uno. It then processes that signal using an ADC, an analog to digital converter, at a high sampling rate. And then that data can be graphed and shown to basically say this is how it is pulsing. In the bottom of the third column is an example of the data being collected from the Uno, going through that process and being graphed. That exact graph is from a prototype board, since we just completed the PCB yesterday. And so that's just to confirm that this testing system can be used to confirm timing and confirm that the light is producing the same level of light for each pulse.
So for the discussion section of our graph, this project is ongoing. We're not quite done yet, but we're getting there. Our initial testing results indicate that we do have we're meeting a lot of our criteria. It seems like a lot of our goals have been met. It's just kind of polishing and putting the final touches on this project. As I mentioned before, we are working on ordering the second revision of this board. We'll include a section for the microcontroller and a section for our power supply. One of the abilities that we'd like to have is the ability to choose between an external TTL source, as requested by the client, and an internal, onboard TTL source that comes in the form of a microcontroller pulsing a pin. Just toggling a pin on and off. It's pretty basic code written for it. We decided to use the AT-Tiny 84A chip from the Atmel line of microcontrollers. It was selected because of its physical size, as well as some other parameters that it matched up with a lot of things that we needed to keep to a minimum in terms of this project. We didn't necessarily need a really fancy microcontroller that had all the bells and whistles on it. Just a simple one that has a very basic I/O capabilities. And as I mentioned, we use KiCad open source software to develop these boards.
And then if we were to suggest future research options regarding our project, the first would be incorporating fiber optics. Using fiber optics would increase the speed of the driver and also decrease electrical interference while in use in the atmosphere. Another option for future work would be to look into an onboard selection system to adjust pulse duration and the duration between pulses. Lastly, we were not able to test the driver at 50 milliwatts, so future research might consider this a worthy test to determine the capabilities of the driver. Is there any questions?
I think we have time for 1 or 2 questions. Does the audience have any?
I have a question, and it's going to reveal my ignorance. But what exactly is a laser diode used for? And I understand that we want pulsing, but what is the significance of minimizing? I mean, I understand overall it's better to minimize power consumption and physical size, but why? What application is that meaningful for?
So this thing is going to be sent up on a weather balloon. Basically, it's going to take images of water droplets. So we need a small physical size because it needs to be lightweight to go up on the balloon. And the reason we're using a laser is because we need to take pictures really quickly. We basically want to expose the image in a short enough time that the water droplet won't fall more than a single pixel within the image. And the idea behind using a laser is it produces only a single wavelength of light. And so we put a filter on the camera so that it will only pass the wavelength that's produced by the laser. So we could have a very bright pulse of light for a very short duration that'll be picked up by the camera. And what we mean by diode driver is that it's basically the circuit that will power the laser. It'll make sure that the laser is on at the right brightness with a steady output, and that it'll turn off at the right amount of time.
Okay, thank you.
Yeah, thanks for that. That was a good answer. Just like a very short question, but what is it going to take, or how much work do you think it's going to take to get a real-time test circuit?
Well, we pretty much already have it. I think the
Yeah.
difficulty with it is just sampling fast enough.
Mm-hmm.
But we already have the circuit for it in real time. We just haven't implemented it onto the board. We could just connect it to the pins that we have currently on the board. But we should have it working right now.
Great. Great.
Isabel, it looks like we have a question in the chat.
Yeah. So there's a question in the chat. So the laser diode driver is going to be on a weather balloon in order to take photos of water droplets with a laser. And I think Eric answered that pretty well.
Yes, that's correct.
All right, thank you, team poster number 128. Our next presentation is from atmospheric physics, called Data Constrained Simulations of Lightning Impacts.
Hi, I'm Michael Taylor. I was working with Dr. Caetano da Silva on this. What we did was we took data from a research that was taking place in Florida, where we got a rocket-triggered lightning sample of current to ground, where they also measured the electron density and temperature of the lightning channel. And we tried to compare a model that was put in place in my professor's paper to match up as best as it could to reproducing the temperature, electron density, and other measurements that vary from those. So what happens in the original paper is the model solves 6 zero-dimensional equations listed there, equations 1 through 6. Some notable mentions are Ohm's law and electron density population. What we did was we took 3 different models. We had 3 different models, the first being the original model that is listed in that paper, and the next 2 being models that calculated conductivity and electron density from a paper by Dingala. The difference between these 2 models is the first has an atmospheric pressure of 1 and the second has an atmospheric pressure of 5. Sorry, my video wasn't on. And you can see the differences between the models in figure 1. This shows why we needed to implement the models, because in section B of that figure, the original model did not have the peak electron density that we were looking for. It wasn't able to reach that. And so we took the data that we got from optical spectroscopy through this paper by Walker and Christian. It had 5 separate lightning strokes, and we looked at the return strokes for that. It was in Florida. So what they did was they took a spectroscoper to a high frame rate camera and pointed at the lightning strike to be able to look at the different densities of ions and atoms there to calculate the electron density in similar equations through 1 through 6. And we did a parametric study comparing to this data through all 3 models and all 5 strokes to vary the initial temperature and channel radius and output the temperature and electron density of the channel. And a figure that describes that is figure 2. We can see this is the best stroke for the best model. It has the least normalized combined error, and it shows us the best initial conditions for the strike. And so what this tells us, looking at figure 3, is that the energy dissipated through the 100 microseconds, the first 100 microseconds, is between 700 and 5,300 joules per meter. This wasn't surprising at all. This is a good range, depending on the initial input current. What we also found was that the initial conditions don't really have any memory of previous lightning strikes. So as you go from one lightning strike to the next, each stroke, they don't really recall that one happened previous. There was no increase in temperature or increase in channel radius between the strokes, which was very surprising to find. We'd assume that as you progress along from stroke to stroke, the channel radius would increase and the temperature would also increase, but that's not what we found. Some things from the parametric study is that the initial radius and temperature, as they both increase, they both decrease the accuracy of the model. So we had to find where the best fit was for those initial conditions. We implemented something that's different from this model, is that from the Caetano model, the 2019 paper, is that we implemented an atmospheric pressure variable. We thought that maybe increasing the atmospheric pressure would help us with the electron density, but we found that once we went from 1 atmosphere to 5 atmospheres, that the electron density did increase, but the temperature drastically decreased. So we had to find a sweet spot there, which was unsurprisingly at 1 atmosphere. We found that T1 was the best model because while it wasn't able to reproduce both the electron density and temperature extremely accurately, it was able to match the rise time fairly well of the temperature, and it was able to get close enough to the electron density measurements. And in future work, we want to improve this model using measurements taken from Langmuir Labs with rocket-triggered lightning, because we weren't given that many measurements from the paper. And we'd like to work with Langmuir Labs to implement this and improve our model and help their research as well. Are there any questions?
Thanks, Michael. So I'm curious if there's kind of a certain set of parameters that you're trying to match or that are like most important to match. I know you mentioned things like temperature and rise time and electron density, but like for your purposes, is there a particular set of parameters that are most important?
So those temperature and electron density are the most important because that's what they measured from the temperature of the lightning strike. Those were the parameters, but we also have a large table that I wasn't sadly able to fit into this poster of all the different parameters that we were trying to match of energy, conductivity, and all those sorts of things, but the ones that are displayed here are the main ones that we were trying to capture because they're what was given in the data set.
Great, thanks. Is there one more question?
The additional samples or data set that you're trying to get, does that have more of those other variables included in it, those other measurements?
Not really. There are some, and those are again listed in the table. But these are this project that they were conducting was a new way to calculate the temperature and electron density, and they were very confident in their answers, and they matched up well with the previous measurements as well. So that's what we were mainly looking at, was the temperature and electron density. That's what we were trying to get, and then from those measurements, we were able to calculate those other variables. So these are the two main ones, but they also had their own set of variables that we were also trying to look at.
Great, thank you, Michael.
Thank you.
So our next poster is number 158 from biology. So this is the effects of physiological deficits in pineal melatonin on triple negative breast cancer.
So yeah, good morning to you all. I'm Pineal Silva. I'm a student of biology department, grad student, and I'm working with Dr. Stuart Thompson. So I'm going to present our research project. So breast cancer is common and deadly. And one interesting risk factor for the development of breast cancer is exposure to artificial light at night. Why I am saying that? Because studies have found that blind women have lower rates of breast cancer compared to sighted women. And also studies have found that the communities which are using higher levels of artificial light at night have higher incidence of breast cancer. And mounting evidence suggests that suppression of pineal melatonin as a major contributor for this effect. And when it comes to breast cancer, it has multiple flavors. One of the deadliest flavor is triple negative breast cancer. We call them triple negative breast cancer because they lack all three types of hormone receptors. And interestingly, it has found that there is a correlation between triple negative breast cancer and the development of there is a correlation between triple negative breast cancer and melatonin. So evidence in favor of this correlation, number one, there is a correlation between night shift work and triple negative breast cancer incidence. Number two, low melatonin receptor expression correlates to a poor prognosis of TNBC. Number three, high melatonin doses can reduce the TNBC growth. So, but here they have used in these, most of these studies, they have used higher levels of higher concentration of melatonin. So in our lab, we wanted to determine whether small deficits in pineal melatonin alone has an effect on triple negative breast cancer. So for that, we did both in vitro study assessment and in vivo study assessment. In vitro study, in both these assessments, we use 41 triple negative type breast cancer cells. In vitro studies, we compared 41 cells that are treated with melatonin to 41 cells that are not treated with melatonin. However, we did not observe any significant effect of melatonin on 41 cell viability and cell invasion. but we observed a significant gene expression changes. And in fact, we observed a significant reduction in PAM50 risk of recurrence score. That means melatonin can dramatically reduce the aggressiveness of triple negative breast cancer. And on the other hand, in the in vivo studies, we compared mice with pineal melatonin pineal melatonin to mice without pineal melatonin. In here also, we for the in vivo studies, we observed a non-significant increase in incidence of solid tumors among the mice who do not have pineal melatonin. So in a conclusion, we can say that there is a possibility of melatonin effect in the early stages of triple negative breast cancer development rather than later stage. So as a take-home message, what I can say is this using prophylactic risk reduction strategies such as reducing the exposure to artificial light at night or melatonin supplements would have meaningful mortality and morbidity benefits. Thank you. I would like to take any questions.
So there's one from the chat. Does artificial light include light from your cell phone?
Yeah, so the main type of artificial light that inhibit melatonin secretion is blue light. So it includes phones, computers, TVs.
Right. Another chat question is, would you recommend people take over-the-counter melatonin supplements?
Actually, it's a tricky question. Thank you for asking that, because in the over-the-counter melatonin, I think lowest dose is about 1 milligram. And it will cause supra-physiologic concentration in the serum. And, and also it has a shorter activity time, and that may cause more side effects than its physiological effect. However, that is the only only preparations that we have currently. So what I suggest is lower doses. I mean, the least dose that you can have without side effects would have beneficial effects.
Thanks. Is there maybe one more question? You know, there's active chat happening on this poster. So thank you all for answering and sharing. If there's not another question, thanks, Pineal. Our next poster is Mechanical Engineering, number 166. This is Analytical and Observational Investigation of Color Effects on Drag Reduction in Penguins.
Hi, I'm Grace Tenorio. I'm a graduate student in mechanical engineering. My advisor is Mustafa Hassanalian. So basically the question we wanted to answer for this study was, does color affect drag reduction in penguins? And drag reduction is important in regards to energy efficiency, specifically fuel consumption goals for vehicles and boats. So all 18 species of penguins are counter shaded, meaning that they are black on their dorsals or their outsides, and then white on their ventrals or undersides. And they actually evolved to be like this. They used to be more of a reddish brown color. So we split this up into basically 3 different parts. So the first part was a thermal analysis to calculate the penguin dorsal surface temperature. Then we did a turbulent analytic solution. So we looked at a 2D model of a penguin in COMSOL at different temperatures. Verify that there was drag reduction because of color. And then lastly, we went to the Albuquerque Biopark and we measured the surface temperatures of captive penguins to study if there was any increase in body surface temperature after they dived. So what we found was that conceptually, you could get a maximum skin drag reduction of about 18%. And this can be achieved for an emperor penguin in the middle of the Antarctic summer as a result of their plumage, which is their feather color. And the other result we found was that the black color on their back is heated more than the white color on their underside. So there's definitely potential for drag reduction. So for future work, we want to evaluate the potential of color-based underwater skin fraction drag reduction, more for before and after the dives. So I'm going to open it up for any questions now.
Thanks, Grace.
Excuse me, I have a question. Do you think that your findings would be similar through open air, for instance, the reduction in drag?
Yeah, I would say definitely. That's why like there are black cars and like stuff like that, because black does help reduce drag.
And does it matter what the material is? Would it be significantly different depending on whether it was steel or rubber or plastic?
shape and material of the vehicle or like penguin definitely does take it definitely does matter.
Okay, thank you.
I have a question. So thinking about the penguins at Albuquerque Zoo, they underfeed Arctic and Antarctic animals there so they don't overheat in New Mexico. So just wondering if you think that might affect the thermal output you're recording, compared to the wild, which would be the evolved state.
Definitely. The other thing that probably affects it is the artificial light that the Albuquerque Biopark Zoo uses, just so that the visitors can see them better.
Yeah. Okay, cool.
So is there any noticeable structural difference in feathers on the penguins, front, top to bottom, that might also cause the drag difference? So are the white component of the penguin structurally different than the black component of the penguin?
Penguins have two different layers of feathers, so it's definitely possible that the feathers are different, but I don't believe they're that structurally different that it would make that big of a difference.
Cool, thanks.
All right, so I think we can move along. Thanks, Grace. And our next poster is also mechanical engineering. And this is number 167, conceptual design of fueling mechanisms for an unmanned aerial vehicle with harvesting liquid methane capability for Titan exploration. Sorry, I think I'm looking at a different version of the title, but go ahead.
Hi, I'm Micaela Olivas, and my research partner is Mariah Gamble, and our advisor is Dr. Mustafa Hassanelian. So scientists have been interested in Saturn Moon Titan because there's a possibility of life under the subsurface water, but they need a way to explore the planet. So what we propose is using an unmanned aerial vehicle, and this vehicle will need a fueling source so that it can continue to survey the planet instead of just being sent with whatever fuel it has, and when that runs out, it's done. our idea is to use the liquid methane lakes on Titan as the fueling source for jet propulsion for the drone. Since Titan is covered in over 300,000 meters of the liquid methane lakes, and it's believed that these lakes are replenished by a cycle similar to Earth's water cycle, this seems like a very viable option for the drone to land in the lake, take up the liquid methane, fly around surveying the moon, and then return to a lake for more fuel. So as most drones are either battery powered or manually fueled, there's not much research about how to get them to fuel themselves. So what we did was we looked into water sampling drones, because they still have to take up the samples. Some even go to various lakes at a time and then return to a different place. So our idea was to use something similar, but instead of storing the water, putting it into our fueling tank. So in the middle of our poster, you can see the three main fueling systems that we looked into. One was a long extension suction tube that would take up the water. Another was a pipe that would be lowered into the water, and then a timing mechanism would close the pipe, and then it would breathe out the water. And the third one was a syringe that was on a servo motor. Now, after looking at all of them needed some modifications if we were to use them, but the long extension tube seemed to be the best way to go, using suction to take the methane in. And the only things that would need to happen was we would need to shorten the extension tube so that wouldn't drag along the ground when landing and taking off or surveying the moon. And then also, since the extension tube would be shortened significantly, we would have to double ensure that our drone was waterproof so that none of the electronics would be messed with. And then I'll let Mariah go over our proposed fueling mechanism.
Yeah, Michaela. So for our proposed mechanism, in order to refuel, the drone would need to be able to land on Titan's lakes and then initiate a refueling sequence, which in our case, we ended up proposing use of a centrifugal pump. And we did this because liquid methane has a really low density, and so a lot of pumps aren't actually able to like pump that into the tank. And so with a centrifugal pump, we were able to we'd be able to into the refueling tank. The pump will be lowered into the lakes using telescoping hinge joints and then swivel joints on the tubes leading into the fueling tank. Another consideration is to include a filter on the end of the pump so that we don't get any unwanted contaminants in our fuel, such as dirt, dust, debris, things like that, as well as introducing a heating process in order to purify the liquid methane. So one of the things about Titan is that oxygen isn't really readily available there, and this does two things for us. One, we don't really have to worry about igniting the liquid methane while it's in its natural environment, which is good for us, but it also means that in order to actually use it as a fuel, we have to bring the liquid oxygen with us from Earth. And so in addition to the fueling tank you can see in Figure 5, we would also need a tank to hold liquid oxygen brought from Earth, as well as a central mixing chamber. And these will need to be placed on the drone so that it's not unbalanced as it flies and uses up fuel and things like that. With that, I think I'll give it back to Michaela to go over the future work section.
So for future work, we need to do some further researching on the heating process to convert the liquid methane into a fuel source drone. We also need to manufacture and test a prototype, and currently in separate research, we are looking into the various materials to make the drone itself out of. This is a lengthy process, and the work will be continued for quite some time. But with that, I'll open it up for any questions.
Thank you both. There's one question in the chat. You may have addressed this, but will the drones be able to utilize the raw liquid methane without any type of processing or refining?
No, it will need processing and refining. And as Brian mentioned, we will have to take up oxygen. And so the flight will be limited by the amount of oxygen that we can bring. In separate analysis, we have calculated that the drone could probably fly for an approximation of 10 days from when it intakes the liquid methane, and the total lifespan of the drone that we're looking at right now is approximately about 75 days for the total once it starts until it's no longer a viable option.
All right. Other questions? So I'm curious what the environment on Titan is like for a flying drone.
Yeah, so Titan is, for a drone, it actually has really good conditions because the atmosphere is there is really, really dense. And the gravity lower, so it's actually pretty easy to fly a drone on Titan. It is pretty cold, so that will have an effect on, you know, material selection and things like that for the refueling mechanism and the drone. But the propulsion system using the liquid methane combustion, it will also help to you know, electronics in the really cold temperatures.
Great. So there's one more question you can probably answer pretty quickly from the chat. Two questions now, but did the group decide on the third method of withdrawing liquid methane, or are you still researching the other two methods?
We decided that our proposed method was the way that we were going to go after fully looking into all three methods are on the poster. The third method, using a syringe, it did work effectively, but the syringe itself didn't have the success rate that we were looking for. Sometimes it would take in what it needed to, and others it wouldn't. And since we're sending it onto Titan and the drone has to fuel itself, we don't have the ability to chance that the drone doesn't take in the methane that it needs. So it was decided that it was not a good option to go with that one.
Okay. And if you want to keep answering questions in the chat, it looks like there are a couple more, but our next presentation, thank you both, is from chemical engineering, and it's reaction kinetics and mechanical properties of reversible epoxies by the Diels-Alder reaction. So if Nicole or Samantha are here.
Hello, my name is Nicole Penners, and I researched the reaction kinetics and mechanical properties of a reversible epoxy, which was synthesized via Diels-Alder reaction with Samantha Lindholm and our research advisor, Dr. Lee. The purpose of this research is that reversible epoxies address a lot of the weaknesses conventional epoxies have. So conventional epoxies are typically very difficult to remove, recycle, and rework. Reversible epoxies make that a lot easier because you could just, you know, heat up the epoxy or apply light to the epoxy, and then you could easily remove the epoxy from whatever it's attached to, supposedly. And so for our research, we first confirmed that the initial reaction to make the monomer was successful, and we did that using FTIR. We then characterized the reverse reaction at 110 degrees Celsius, again using our monomer formed from 1,1-methylene di-4,1-phenylene bismaleimide and furfuryl glycidyl ether. And then at that point, we synthesized the polymer, and to do that, we added our monomer to our hardener, which was jeffamine T403. and we made our conventional epoxy. We made our reversible epoxy, and then we used the DSC. We did DSC scans to analyze, to compare the conventional epoxy to our reversible epoxy polymer. And we did that with 2 versions of our reversible epoxy polymer in order to see what the effect of cross-linking density would be. So as you can see, there's a fairly big effect for cross-linking density on TG, on glass transition temperature. Our original epoxy polymer has a TG around 40 degrees Celsius. And then our second one with a different cross-linking density has a glass transition temperature around 0 degrees Celsius. And we also made these little sample type things in order to test how the mechanical properties of our polymer at different temperatures and different strains. And what we found is that at 100 degrees Celsius, the sample doesn't drop doesn't break almost regardless of what different strains are used. But at 120 and 140 degrees Celsius, it sometimes breaks at either like 2 minutes to 4 minutes typically. Sometimes it'll go above that, or it doesn't break at all. So our research, our mechanical research implies that the reversible reaction does not take place at 100 degrees Celsius and takes place at higher temperatures. And that's it.
Thanks, Nicole. Are there audience questions or chat questions? So I'm curious how you make the epoxy that is reversible. So is it more complicated than mixing something together, or I don't understand chemistry very well, so.
Sure, that's a good question, actually. So with this particular procedure, it's not very complicated. It's just mixing the bismalamide with the furfuryl ether at a specific temperature, and then once it's done, the monomer is heated up so that we can mix that with our hardener. So it's not more difficult than the conventional epoxy we use to synthesis.
Very cool. Are there other questions from the audience? I can definitely see the appeal of a reversible epoxy. Well, if there aren't any other questions, thank you, Nicole. And if people think of questions, feel free to throw them in the chat. Our next talk is from Earth Science, and this is pre-eruptive conditions for rhyolitic Miocene volcanism in the Socorro Magdalena, New Mexico area, and its connection to the La Hencia Basin sediments.
Hello, my name is Kirsten Hottendorf, and today I'll be presenting on the research that you see put up on my poster that I've been conducting with Dr. Laura Waters and Dr. Ryan Leary. You may not know it, but New Mexico has actually undergone a lot of volcanic activity. This is due to the fact that the Rio Grande Rift runs right down the middle of New Mexico. The Rio Grande Rift is an area of crustal extension, which causes the crust to become thin in certain areas. This thinning encourages volcanism. For us in New Mexico, we specifically experience a lot of rhyolitic volcanism. which is essentially just magmas that have erupted that have high amounts of silica. Another consequence of rifting is basin creation. Mexico has a series of basins that run down the length of the state that are particularly good at collecting all of the eroded sediments from the landscape. So back when New Mexico was experiencing frequent and large-scale volcanic eruptions, the basins would have also gathered the volcanic deposits that were being created as well. My research advisors and I wondered what would happen if the basin that was on top of a volcano's underground plumbing, if that basin all of a sudden collected a large influx of sediment. Would the extra pressure from the sediment affect the volcano? We specifically went to research in the La Agencia Basin for a site that had an interbedding of rhyolites and sediment to see if we could discover more about sediment burial and volcanic plumbing. In the picture at the bottom left of my poster, you can actually see the bright white lines on it are the rhyolites and the darker brown are the sediments. This is the interbedding that I was talking about. And from the data we collected in the field, we created a stratigraphic column, which is just to the right of that La Agencia Basin picture. And we found that in the field, there was rhyolite deposits of ash and pumice mixed with sediments that also have a lot of volcanic grains. This combination of volcanic sediments and rhyolite deposits suggests that our sample is from the Pope-Tosa Formation based on information we found in the literature. We also made thin sections from samples collected in the La Agencia Basin to conduct a mineralogical analysis that could give us details on the geochemical nature of our samples. We found that all of our samples were crystal poor and had a high abundance of quartz, pumice, 2 different types of feldspars, and contained a significant amount of biotite as an accessory mineral. This means that all of our samples were relatively high in silica and potassium. Both the stratigraphic data and the mineralogical data match up the most closely with Squaw Peak eruptive center deposits, which are also crystal poor, high in silica and potassium, and are interbedded with the Pope-Tosa Formation. In the literature, we were able to find geochemical data for all of the eruptive centers in the area, and you can see these Socorro Magdalene area eruptive centers in a figure that's to the right of the stratigraphic section. And we entered this geochemical data that we found into 3 different models that outputted the average storage temperatures, water contents, pressures, and storage depths of all the eruptive centers. And we found that the rhyolites from the Socorro Magdalene area eruptive centers generally have pre-eruptive temperatures that are below 750 degrees Celsius, contain between 5 to 9 weight% water, and have storage pressures that range from 140 to 300 megapascals and storage depths that range from 4 to 9 kilometers. But since our samples were determined to be sourced from Squaw Peak, they came from outside the La Agencia Basin, which means that we cannot use this to figure out if sediment burial affects volcanic plumbing, due to not knowing what volcanic plumbing, if there even is volcanic plumbing beneath the basin, to be affected. However, we will use the results of the geochemical analysis of this study in order to select another research location in the future that can yield different results. So now, if there's any questions, I'd be happy to answer them.
Thank you, Kirsten. Are there questions from the audience? I don't know anything about geology, so I can ask some uninformed questions, but I'm sure you all have better questions. So you mentioned that you could kind of take this technique and what you learned from these 2 sets of analyses and apply them to a different basin to figure out this relationship between sediment and the volcanic plumbing. So I was wondering if you have ideas for other test sites or how you would select another test site.
At the current moment, we don't have any current locations mapped out, but what we're looking for is sediments that, or just volcanic deposits and airbed sediments that are in a basin that has a very close volcanic center. And so since we have a relatively good description of the geochemical data and also of what minerals are from each eruptive center, if we went out to a different basin, like for instance, we went out to a basin that was near the Magdalena Peak Center, which is one of the Socorro Magdalena eruptive centers, we would look for deposits that specifically match the description of the Magdalena Peak Center deposits. And so we could be positive that the volcanic deposits we were looking at correlated to what might be underneath the basin.
Mm-hmm. Very cool. Yeah, thanks. Another question from the audience? How many samples did you collect in the field? Or kind of what was that sampling like?
So we collected a original 4 samples, and the samples that we collected, generally we went out to an area in La Hencia Basin where from aerial images we could see the actual intermixing of ash and sediments, as is pictured in the picture I have of La Hencia Basin, the bottom left corner. Mm-hmm. And where areas where a lot of ash was shown, we went and just took a rock hammer, collected a sample, and we mostly tried to focus on areas that had a heavy presence of ash, just so we could, again, see if we were correlating the correct eruptive center to the correct basin. And however, we did end up getting 1 sample that ended up being more sediment than we would like, but in general, we focused on looking for ash deposits in order to, again, get that eruptive center to deposit correlation.
Great. Thanks, Kirsten. So I think we can move on to our last poster, number 173. This one is molecular dynamic simulations of solid-liquid interface of alloys for additive manufacturing.
Good morning, everybody. My name is Danielson Moreno. This project is the project that I've been working on for the past semester. It's entitled Molecular Dynamics Simulations of Solid-Liquid Interface of Alloys, Metal Alloys for Additive Manufacturing. So additive manufacturing is just a 3D printing process where it's created layer by layer, essentially using a metal powder, a metal that has been ground down to a really small grain size. And then from there, you can use essentially a laser to melt the metal, and layer by layer, you can 3D print any sort of object. And I'm doing molecular dynamic simulations of it. And molecular dynamics simulations is essentially simulations that happen in a computer where you get the molecular dynamics and you're able to perform these experiments. So the methods that I used were these different programs. WinSCP is a file management program. PuTTY is a program where I send my files from my computer to supercomputers for the execution of the experiments. LAMPS is the program that does the calculation, and then once the experiment is complete, I get a file back with a bunch of numbers on it, and I can use Excel or MATLAB to analyze the data. Also, Oviedo and VMD are visualization softwares. Oviedo stands for Open Visualization Tool, and VMD stands for Visualization of Molecular Dynamics. And so essentially what I did is I had an alloy of aluminum and zirconium, and I essentially made a metal slab inside using the VMD dynamics, the molecular dynamic simulations. And I essentially got a slab of metal, I heated it up past its melting range, and then I solidified it from a very high temperature to a cooling temperature to where it was solid. And the thing about metals melting is that it doesn't, the melting range essentially doesn't happen at one temperature. It happens at a range. And so I found what that range was. You can see in the top two, on the top right, two graphs. Essentially, I have the temperatures on the bottom, and I plotted the potential energy, which basically shows that at lower temperatures, you have the first set of lines, the first set of dots, and that essentially shows that it's in solid state. And when it jumps up to the next line at higher temperatures, that means that it's melting. And that range where it jumps, that's the melting range. So I was able to compare that to literature values and found that the range was in a normal range, which basically means that I was able to set up this experiment with good parameters, and that the foundation of my research was essentially in tune with reality. And so once I found the melting range, there's a specific temperature where a metal can exist in both in solid and liquid phases. I found that temperature to be 954 Kelvin. And then once I found that temperature where it can exist in solid and liquid phase, I was able to graph the solid liquid interface, which is shown with the contour maps in the middle right-hand side of the screen. So that's where the solid liquid interface exists. And with that information, I can get a stiffness tensor, and then I can calculate the interfacial free energy at the solid liquid interface. And then another thing that I did was a density profile. So essentially what we have is a binary system with aluminum and zirconium. Zirconium is about 1% of the total mass in the system. And doing research, we found some papers that essentially explained that depending on the density at the solid liquid interface of the two components, you could have dendritic structure growth, which a dendritic structure is kind of like a crystalline, kind of like a branched out, kind of like a snowflake, where essentially it doesn't grow just in one direction. It can grow in several directions as it solidifies. So in order to characterize the solid liquid interface, I would first found the melting range, and then I found the equilibrium temperature at which it can exist in solid and liquid phase. And then from there, I was able to do a 3D contour plot of the solid liquid interface. And with that information, I will in the future further characterize the solid interface by getting the stiffness tensor and then converting that information into the interfacial free energy at the solid liquid interface. And I also calculated the local density to see if that correlates with dendritic structure growth. And so in the future, I will continue to calculate the free energy at the surface, and then to use the density profile to see if these types of densities will cause dendritic growth or more monolithic growth in the structures. So with that, that's basically my presentation, and happy to answer any questions.
Thanks. There's a chat question. How does this research impact additive manufacturing?
Okay, so essentially, I'm looking at the solid-liquid interface, and depending on how a metal will solidify, will on a microscopic level, it can affect the characteristics of the macroscopic level. So if it has a lot of dendritic growth, then it might be more ductile, or it might have more tensile strength. So in order to understand what's happening on a macro structure, we can study these microstructures essentially to know what the qualities are going to be, and if they match up to qualities that are wanted.
Great. Are there other audience questions?
I have a statement that could potentially turn into a question depending on how long I talk. I'm wondering, or I'm interested in, once you discover what that interface looks like, are there interventions that you could perform that would change that result? And is this something that maybe could be future work for your research group?
So yes, we can definitely affect the dendritic growth structures, and we can also affect the interfacial free energy at the surface. For example, if we were to do a fast cooling of the system, there might be less dendritic growth. If there is slow cooling, then there might be more dendritic growth. And so depending on what the qualities that we're looking for, we can either do fast cooling or slow cooling processes, or we can even change up the percentage of the zirconium and the aluminum. So instead of 1%, we can change it to 2% or 0.5%. And all those things will affect the solid liquid interface and will either give us more of qualities that we're looking for in 3D printing processes or not. But depending on those things, we can change those variables and get more desirable results.
Thanks. So I had a question that was related to this next chat question, so I'll ask that. So which metals or alloys have you studied, and what are the most important 3D printed alloys? Or kind of why did you choose aluminum, zirconium?
So aluminum is a good metal because it's nice and light, and zirconium can help strengthen aluminum. As we all know, aluminum is a pretty ductile and sort of metal, but it comes in really handy in things like planes, if you need like a lighter metal so that it can fly. And the reason why I chose this one is because that's what Dr. Chattery assigned to me. But other team members in our research group are looking at different systems, running all these, essentially these same experiments that I'm running to see, what the differences are in the different components, and to see just, which one might be more desirable for 3D printing processes.
Yeah.
So zirconium, then the base that you'll use along with those other metals to try to make it so that you can see the differences in structure?
I think the other group members, one is researching aluminum maybe it's aluminum copper, but it might be the same primary metal, which is aluminum.
Okay.
I'm not sure.
No, thank you.
Great, thanks, Danielson.
Thank you very much.
So that was the last poster for our session. So thank you all. I think David has some closing words.
Well, I'd also like to thank everyone for attending today's session, the first one we have for our SRS presentation for 2021. I'd like to thank Dr. Morris and Ms. Lyons and the student presenters. I enjoyed watching and hearing you discuss the research you were doing, and I appreciate you taking the time to share with us. Now in the chat box and on the screen here, I think you'll see some of the other events at this year's SRS. And those are listed on the slide in front of you. And I hope that you would consider, of course, attending those types of events. And we thank you again for being with us, and stay safe. Thank you.